welcome to my YouTube channel. This video I'm going to introduce some basic information about set theory. Firstly, what is set? We can say set is a collection of objects. We can also set this object as an element of a set. It's quite simple to understand because we can see set as a box, and we can grab anything we want into this box. For example, like this, and then we can label this box as A, which has the element 1, 2, 3. But how do we express an object is an element of a set? We can use some notations. First notation is this one. It means belongs to or is an element of. Conversely, this guy's indicated doesn't belong to or isn't an element of. We can look at example here. If we have a set A has element B and C. In this case, we can say B is an element of A. C is also an element of A. But any objects are elements of A except B and C. So like we can say 4 is not an element of A. D is not an element of A, for instance. Now we can talk something about equal set. How do we know two sets are equal? Suppose we have a two sets S and T are equal, denoted by S equals T. If and only if every element of S is also an element of T. Conversely, every element of T is also an element of S. If both of criteria are satisfied, then we can say set S equals set T. But when we look at the specific example, we still have another two extra points needed to consider. First one is repeated elements. For example, if we have a set A has the element 1, 2, 3, and the set B has the element 1, 1, 2, 2, 3, 3. Then we still say set A equals set B, because we don't really care how many times 2 occurs from a set. A set really collection of a distinct object. And the second rule is that order doesn't matter. For example, if we have a set A has element 1, 2, 3, and set B has an element 3, 2, 1. And another set is C has element 2, 3, 1. They are all equal sets. We say set A equals set B equals set C, because you don't really care about the order of an element. You can really change any order you want. We already know we can grab any elements we want into our set. But how do we count the number of the elements in our set? A new idea here is cardinality of a set. It indicates the number of elements of a set. Let's look at example here. If we have a set A which has the element -2, 3, and 7. Then there are 3 elements in our set A. It also means card A equals 3. We have a set B which has element x which x squared equals 4. So there are 2 elements in our set B which are -2 and 2. It indicates that card B equals 2. And we still have another set C, but we don't have any elements in our set C, then we can call this set is empty set. Then the card C should be 0 because we don't have any elements in our set C. But how do we know how many elements we can grab into our set? Actually, a set can be finity and infinity. A finity set is if a set is an empty set or a set has the same number of elements as the set of the positive integers. For example, if a set A has elements -2, 0, 1 over 2, 1 over 3, then card A is 4. So in this case, n equals 4. It's enough to show A is a finity set. Another example, if B has an element of x and which x squared equals 4, then there are 2 elements in our set B which are -2 and 2, then card B is 2 as I said before. Then in this case n equals 2. It also shows B is a finity set. Then we can conclude that if we can find what the number of n it is, then we can say a set is a finity set. But what is an infinity set? It's quite simple. So if a set is not a finity set, then we can say this set is an infinity set. For example, if we have a set here, a set A has an element 1, 2, 3, 4, etc. Actually, we have infinity numbers of elements in our set A. So we can't really find a card A, so which means we can't really find the value of n, so that means A is an infinity set. I will continue to introduce some commonly used infinity set in our number system. The first one is the set of natural numbers. Start with 0, 1, 2, and etc. And the second one is the set of the integers. Including all negative integers and positive integers and 0 as well. And the third one is the set of the rational numbers, which including all integers and some fractional and all fractional numbers like 1 over 2, 1 over 3, etc. And the final one is the set of the real numbers, which including all the rational numbers and also included the irrational numbers such as pi, e, square root 2, square root 3, and etc. Thanks for watching my first YouTube video. At my next video, I will introduce the concept of subset. I will give you guys two examples, show you how to prove a set is a subset of another set, and how to disprove a set is not a subset of another set. This is my first experience, and you can leave your comments. I can review them, and I can make my next video much better than this one.